Hi Internet, my name's Abby, and welcome back to my channel. The North Star, also known as Polaris, also known as a pole star, or any of these other names, has been of cultural significance to different populations over the millennia. Just to name a few, the ancient Egyptians are thought to have built the Pyramid of Giza to align with it. Early explorers would use it to guide their journeys into the unknown, and in the 1800s, slaves would use it as a symbol to escape for their freedom. The unique placement of the star, almost directly above the North Pole, gives it a stationary point in our night sky, and it appears fixed, unmoving, while the whole sky rotates around it. Even though humans have known about the star for ages, we are still making new discoveries about it all the time. And after my deep dive, I've learned that there's a lot more to it than what meets the eye. What you can't tell from simply stargazing is that Polaris is actually a triple star system, meaning that the single point of light is actually 3 giant fireballs zooming around in space. In 1780, William Herschel, yes, the same man who discovered Uranus, no, not that one, I mean the planet, looked through his telescope and was the first to note they were actually 2 stars, not just the one. And in 2006, the Hubble's telescope went to image the star system, but when the picture came back, astronomers saw a 3rd small star tucked in between the 2 previously known ones. The system as a whole is named Polaris, and the stars themselves have the extremely clever names of Polaris A, B, and Polaris AB. By far the largest and the brightest star in the system is Polaris A, and is classified as a F7Lb yellow supergiant at 3.45 times the mass of the Sun and about 2,500 times brighter. It is this star I'll be focusing on during this video, but in case you're curious, Polaris AB and Polaris B are white dwarfs with classifications of F6V and F3V respectively. The other thing special about the star is that it twinkles, but Polaris twinkles in a very special way that's actually really useful to astronomers. It is what's known as a Cepheid star? Cepheid?
Cepheid.
It is what's known as a Cepheid Variable star, a classic population 1 to be exact. The star seems to pulsate with a period of about 4 days, and astronomers, much smarter than I, can use some really fancy math to determine the absolute luminosity. By the way, this relationship was found by Henrietta Swan Leavitt in 1908 at Harvard University. From here we can use this relationship of the absolute luminosity and apparent brightness to determine the distance between us and the object in question. We know, due to the Doppler effect, that sound goes up in pitch as the source moves towards us and down as it moves away. I mean, think of an ambulance siren as it passes by. But this is also true with light. Light from sources that are further away will actually have longer wavelengths, so it'll appear much dimmer and actually redshifted. Therefore, Cepheid variables are used as standard candles. They can use this difference between the apparent brightness and the absolute luminosity to definitively calculate a distance. That means if a distant object is near one of these standard candles, or if a galaxy contains one, we'll be able to know their distance as well. But how and why do these stars pulsate? It's because they're in a cycle of heating up, causing expansion, and cooling down, causing compression. Stars produce energy from a process called nuclear fusion, which is a whole separate topic in itself, but this is where the light comes from that you see. In the short term, this energy production is relatively constant, so you can imagine that the outer layers of the star are heating up, kind of like if you put a pot on a burner. And when these outer layers are heating up, you can imagine all these molecules that make up those layers start wanting to move around really, really fast. And it's this that causes an outward pressure force. And once this pressure is greater than the gravitational force, the whole thing starts to expand. And when this happens, I'm gonna have to pause myself right there because I'm about to say something that's incorrect. This is Editing Abby coming to you live from her living room. Anyways, what I was saying is the expansion and compression of the star itself causes the outer layers to heat up and cool down. But this isn't what directly causes the light to become dimmer and brighter from our perspective. That is actually caused by something called the editing valve or K mechanism. So stars have a lot of helium in it. So when this helium gets heated up, starts to become ionized, which just means one of the electrons just ditches the atom. And the property of ionized helium is that it becomes more opaque. So star heats up and starts to expand. It starts to become more opaque due to this chemical reaction, and therefore appears dimmer to us. As the stars cools down, it'll start to condense again and become clear and appear brighter. Polaris is definitely the closest Cepheid star to Earth at approximately 445 light years away. It is thought to be about 70 million years old, which is actually pretty young in comparison to our sun's age, which is about 4.6 billion years. It is the brightest star in the Ursa Minor constellation, but only about the 48th brightest star in our night sky. In the time of the ancient Egyptians, it was believed that when pharaohs died, they would join the pole stars in the northern sky, known as the Indestructibles. So when the Great Pyramid of Giza was being built in around 2560 BCE, they added a shaft that pointed to where the North Star would have been at that time. The irony is that the North Star isn't as fixed as it appears. It turns out that our Earth is slowly wobbling on its axis, about 1 degree every 73 years, meaning that the star directly over the North Pole actually changes over time. The North Star in the time of the ancient Egyptians was actually Thubian, which is located in the Draco constellation. Polaris took over the title in about 500 AD, and Gamma Cephei of the Cepheus constellation will take over in about 3,000 years, and then Vega of Lyra in about 12,000 years. But don't worry, give it another 26,000 years and Polaris will be back. For as long as people have been navigating using the stars, they have been using the North Star to keep their orientation. You can tell your relative latitude based upon how high it is in the sky. So if you're in the North Pole, the North Star is going to be directly overhead, and if you're at the equator, it'll be right along the horizon.
So, the elevation in degrees of the North Star above your horizon is your latitude on Earth.
In the United States, the North Star became a huge symbol of freedom and hope during the time of the Underground Railroad. When enslaved people would escape from their captors, the North Star would always be there to guide them to safer regions of the United States and Canada. It is such an important and iconic symbol that Frederick Douglass founded an anti-slavery newspaper called the North Star in 1847. Over the years, Polaris has been mentioned in countless works of literature and has picked up themes such as guidance, hope, luck, freedom, consistency, and life's purpose. Some notable mentions from Shakespeare himself include Act 3, Scene 1 of The Tragedy of Julius Caesar, where Caesar is thought to be constant like the North Star, and was used again in Sonnet 116 in a metaphor of true love being unchanging with time. The irony, I know. As mentioned earlier, Polaris is in the constellation Ursa Minor, which is better known as the Little Dipper. But if you want to find the star next time you're looking at the night sky, it might be easier to locate the Big Dipper and follow the line made by the too far pan star. It will point you to the handle of the Little Dipper, and it's the very last one is the North Star. If you're similar to me and just like to look up at the night sky every once in a while, you might be wondering about all the mysteries that lie beyond what we can see. I hope that this video and any others to follow both answer some of your questions and spark completely new ones. That being said, thanks for watching. Don't forget to like and subscribe if you would like to. No pressure. I'll see you next week.
It is completely uninteresting. It is easily missable.
Alright, Neil. I respectfully disagree, okay?